integration means area under the curve. Okay, so when you're trying to find area under the curve, there are 5 properties, right? Sum and difference. So sum and difference we've talked about. So if you have 2 functions over the same bounds, start to finish, beginning and end, you could split them up and do them as 2 separate problems instead of one big problem. You don't have to, but you can. Constant multiple. Constant multiple means just a constant. So if there's a constant in front, you can put it, you don't have to take that into account. You can put it in the front. You don't have to, but you can put it in the front before you do your integration. Number 5, it just says, so you see number 5. Number 5 is the same function, right? Number 5 is the same function. So if we have A, B, and C. So if I have a function, let's just say the function goes like that. Okay. If I find the area under the curve from A to B, right? That's that part. And then if I find the area under the curve from B to C, that's that part. Right? That is also the area of A to C overall. That's all it's saying. Okay, so if you have 2 smaller regions and they have the same function, though, they have to have the same function, oops, right there, you can add them together. Okay, that's all that's on. Okay, so number 3, or let's go to number 4 first. Number 4 is pretty simple. If my bounds don't change, there is no area. Okay, if my bounds don't change, there is no area. So let me give you an example. Let me give you an example of what that means. Let me draw that one right here. So if I have a function and I start at A, right? And the function goes from A to A. Beginning and end is the same spot, right? That's just going to be a straight line, right? So let's say the function, it goes like this. That's B. And that's A. So the function from A to B is all of this, right? But that's not what they're asking. That's not what they're asking for number 4, for property number 4. They're just saying from A to A. So you're finding the area of that line there. And by definition, lines have no area, okay? Lines have no area at all. So that's why it's 0, okay? All right, you don't really see that one a lot, but if you do, it's super easy, it's just 0. The biggie which we're gonna see a lot is number 3. Number 3, reverse interval. So look at the bounds. What are the bounds doing from each side of the equal sign? What are the bounds doing from each side of the equal sign for number 4 or 3? They're flipping, right? They're flipping. We always need the lower bound first. The lower bound needs, the lower number always needs to go in front, or on bottom, right? Anytime we're doing integration, the lower number, value, bound, whatever you want to call it, has to go on bottom. And the upper bound, bigger value, whatever you want to call it, bigger number, has to go on top. What happens is sometimes those will be reversed. So sometimes, like you'll see one later today, it'll have -9 and -11, right? -11 is smaller than -9, right? So these guys need to be flipped. We can do that. We can absolutely do that. How do you do that? You put a -1 in front. Put a -1 in front, and then you can move the bounds. So I could switch the bounds, but it has to be a -1 in front, okay? Sometimes that'll happen. You can't go backwards. So we can't go from, so if we're looking at a graph, we have to start left and move right. Always, always, always. We can't start right and move left. That's going back in time. We can't do that, okay? So if that's not the case, another example, a positive example would be 6 and 4, okay? 4 needs to be at the bottom. 6 needs to be at the top. To do that, you just put a -1 in front, and then you continue what you're doing. Okay? All right. So don't take for granted that they're giving you something that's in the correct order. Sometimes they won't. All right? Okay, so for today, the nice thing about today is we don't have to do area, we don't have to find area in the curve. They're going to tell us what the answer is. They just want us to use the properties. So we don't have to do antiderivatives. We don't have to do rectangular or trapezoid approximation, right? Like you're going to have to do on the quiz, because they tell us. Sometimes pictures help. Okay, sometimes pictures help. So I'm finding the area from 2 to 6 for f of x plus g of x. Okay? So there's 2 different functions. They both have the same bounds. And then up here, they tell you a little bit too. They say, that's true, and that's true. So, in other words, they're asking you, what is the area from 2 to 6 for f of x dx, plus what's the area from 2 to 6, oops, g of x dx. I'll give you a hint for tomorrow. What's the dx mean? Why do we put dx on there? I'm not going to tell you, but if you don't know, it's in your notes. That's just a hint for tomorrow. That's the kind of question I'm going to ask tomorrow. Why is the dx? What does the function tell us? What does f of x tell us? What does dx tell us? What do the bounds tell us? That question, okay? So look that up in your notes for tomorrow. Okay? But they all have something they do. Okay? All right, so we know that this guy, the area under the curve from 2 to 6 from f of x dx is positive 10. Mm-hmm. And we know that the area from 2 to 6 for g of x is negative 2. So we add those together, and the total area is positive 8. Okay. B is the same, you're just subtracting. Uh, 2 to 6, f of x dx. This guy is negative 2 minus, this guy is 10, you get negative 12. Okay. Letter C. You don't have to move the 3 to the front, but you can if you want to. So it would be 3 times the area from 2 to 6 for f of x dx. So that is positive 10, 30. And then d, I believe, is the same as, I think it's a typo. It is the same, right? Okay, so change this problem a little bit. Change d a little bit. You probably know what I'm going to do. F of x minus g of x, will you get the same answer? Do that one right now. So did you get the same answer as B? No, even though you're subtracting the same 2 functions, order matters with subtraction. It matters which one's subtracting first, which one's subtracting second. One of them has a positive, one of them has a negative. So order matters when you're multiplying, or sorry, when you're subtracting and dividing. Okay. All right. Okay, so look at A. From 0 to 7. Always look at the bounds first to make sure it's in the correct order. The smaller number should be on the bottom. The bigger number should be on top. Okay? If that's okay, you can go on. But if it's not, you got to change it. So for 2a, it's 0 to 7. That's correct, right? 0 is smaller than 7, so we're good there. Problem is, they don't tell us anything. They don't say 0 to 7, 0 to 7, right? So what do we do? Well, so what they're saying is, what do we got? 0, 5, 7. So what they're saying is the area from 0 to 5 is 10. I'm making up this. I'm not, don't quote me on this. This is not to scale, but I'm just trying to give you a picture. So what they're saying is the area is, that area here is 10. And then the area from 5 to 7 is 3. Is 3. So looking at the graph, what is the area from 0 to 7? 13, right? Without that picture, it's a little harder. So don't be afraid to draw pictures. These are very easy, but sometimes they can be, sometimes they look like the hardest problems without a picture. So if you see it in your head, they're easy. But if you don't see it in your head, draw a picture. Okay? Okay, letter B. Is the answer going to be 10 for letter B? No, why not? Because you got to flip the bounds first, right? The bounds are not in the correct order. They have to be 0 has to go there, 5 has to go up there. I can do that as long as I put a -1 in front. Okay. So the area from 0 to 5 is 10 times the -1 that was already there is -10. So the area is not +10, it's actually -10 because of the bounds. Okay. Do C and D. Do C and D, and then I'll meet you at number 3. So the area from 5 to 5, there is no area because it's nothing to shade, right? It's just a line. So that one's going to be 0. The 3 you can move to the front. So it's going to be 3 times 10, which is 30. Okay. All right. So now let's look at some graphs now. Now they gave us some graphs. So the given is the graph. Okay? All right. Okay, so we have to find that guy there. Okay. Well, first, the 5 can move to the front. Are the bounds in the right spots? Or they're in the right spot, so the right order, I should say. So I don't need to change that. Good. So we're going to look at the graph from -6 to +3. Well, -6 is going to be this area here. I don't want to do that. Let's see. This area here, this area here, and this area here. Okay. So we got 3 different areas that this covers. So how are we going to figure out what the total area is? So add them together. So when I add them together, I get 29. So 5 times 29. Is that the correct answer? No. Why not? Yeah. So either subtract the bottom or turn them negative. So 15 needs to be negative, or you can subtract. You can do it 2 ways. You can subtract these two guys and then these two guys and then add them together, or you can just turn them negative and add them together. Doesn't matter which one, but make sure you do one of those, because that's really negative and that's really negative, right? So it really should be negative 15 plus 9 plus negative 6. Or negative 5, sorry. So what do we get? Negative, is that negative 1? No. Negative 6, negative 11. So negative 55 total. So the area is going to be negative 55 total. Yay. It's 5 times whatever the regular area would be. Okay. All right. Okay. I think the areas are different, but we're going from 6 to 4, right? From 6 to 4. So we have to, negative 6 to 4. So we got to find the area from negative 6 to 4, f of x minus 1 dx. Okay. So what are we going to do? So are the bounds correct? Are the bounds in the correct order, or do I need to flip them?
No, they're correct.
They're correct, okay. So I'm going to use rule number 1, or property number 1. Property number 1 says if there's adding or subtracting, you can divide them up into 2 smaller problems. So I'm going to do that minus okay. Okay. So this guy here, negative 6 to 4, that refers to the graph. So from negative 6 to 4 involves all of this area here. So that's going to be negative 9 plus 9 plus a negative 8. Which is negative 8. How do we find the area of this guy? I'll give you a hint. You're not going to look at the graph. You can look at a graph, but that graph won't help you. What does this mean? How do I find area from negative 6 to 1 for this guy? This part right here is going to be on the quiz tomorrow. So how do I find the area of something that is just not a, it's not a, there's no, it's just a constant. How do I find the area of another curve of a constant? So what I would do is draw a picture. This is definitely going to be on the quiz tomorrow. Properties won't, but this part will. Let me draw it over here. So I have from negative 6 to positive 1. So from negative 6 to positive 1. What's the function? The function tells me the height, right? How tall is it going to be? How tall is the function? 1, right? Just 1 unit, right? It's constant, 1 unit. So it begins and ends at 1. What shape is that? Rectangle. Rectangle, base times height. What is the length or base? 7. How tall is it? 7 times 1 is 7. That's how you find area of a constant. If it's just a constant, draw a picture. It's always going to be a rectangle. Okay? Minus 7 equals negative 15. Okay. Example 5, the last one, example number 5 is the same thing, they just don't draw a picture. If you need a picture, draw a picture, okay? It's the same questions, just the given is not in a picture form, okay? Number 5 is the last one. This is the last one we're going to do. The last page is just extra practice. So you can do it if you want, but it's nothing new, okay? So f be a continuous function so that from -3 to +3, the area is 5. And from -6 to +3, the area is -2. What is the value of -6 to -3 f of x minus 2? So first of all, that guy looks like the one we just had. So I'm going to break that into 2 smaller ones. F of x dx minus 2 dx.
For example 4, why was the bound? Why when we were doing the 1 bound? Why was it 1? Was it -6 to 1?
Oh, sorry, it was supposed to be 4, right? Yeah, you're right. It's supposed to be 4.
I was so confused. I was watching that and I'm like, what were you supposed to go?
So that guy is supposed to be 10, right? 18. Okay, 18. Yeah, if something like that makes sense, just stop me. Okay. All right, we got about 5 minutes, so let's finish this one in 5 minutes because it's the same as the last one. The only difference is they don't give you a picture. Okay, but it's the same question. Okay, so how do I find area from -6 to -3? Or +3, why, I did it again, see? +3 for f of x.
It's there, isn't it?
What is it?
It's already not there, right?
Oh, sorry, yeah, it is -3, yeah. I was right. So that one's not there, right?
No.
So how do I find area of that?
That one minus the top one.
There you go, right? The big one, so this, yeah.
Small, yeah.
So this guy is the big.
The big G.
This guy is the piece or the small.
Oh, you should have made it.
Big piece, small piece, right? If you don't understand what the heck that means, you need to draw a picture, okay? So if you can't see that in your head, it's okay. I'm not saying you have to, but I'm just saying, picture, okay? So what I mean by big and small is that the first one goes from -6 to +3, right?
Yes.
That's the green one. The blue one goes from -3 to +3. Right? Again, I have no idea what these areas look like, so don't, I'm just kind of drawing, sketching, whatever, right? So the whole thing goes from here to here. That's the big, that's the green. The blue is the piece. That doesn't go all the way from -6 to +3. That goes from -3 to +3. Right? So what that question is asking, what's the area of that piece there? This slice here, the one that's not doubles. That's what it's asking. So just like you guys said, it's the big minus the small, right? In other words, -6 to 3, that's the green. So -2 minus the piece, right?
Yes.
-3 to +3, which is 5. Okay. All right. So again, sometimes you need to draw pictures to see it. It's okay. Draw pictures to see it. Okay. Let's see here. Whoops. So let me draw the picture here. So from -6 to +3. That's the green. The blue only goes from -3 to +3. So it's not going to really show up that well because the colors are going to overlap, but this is what it means. So they want to know what the of this slice is here. Okay. Let me do it differently. Let me redo this so it's a little, we only got about 2 minutes. So tomorrow we're going to do the quiz, and then when you're done with the quiz, you can start on the practice that is there. Okay. Yeah, so whether it's a foggy day tomorrow or not, we're going to at least start the quiz. If it's a day like today, we won't be able to finish the whole thing, so we'll start it. But if it's a regular day, we'll be able to do the whole quiz. So either way, we're going to be doing the quiz tomorrow. So you can use your, look at your review. If it's on the review, it's going to be on the quiz. If it's not on the review, it's not going to be on this quiz. That's the best way to study for the quiz. Okay? Yeah, go grab your phones. And then I'll see you guys tomorrow.